In the last video, we drew a histogram for a continuous set of data. Now what we want to do is talk about a stem and leaf plot, which is another way to represent data. So a stem and leaf plot is specifically a way to represent quantitative data. And in a stem and leaf plot, or sometimes they just call them a stem plot, we use the digits to the left of the rightmost digit to form the stem, and the rightmost digit from each data point forms a leaf. So how do we actually go about drawing one of these? We treat the rightmost digit as the leaf and the remaining digits as the stem. This is just a repeat of the last sentence from the previous definition. We write the stems vertically in ascending order and draw a vertical line to the right of the stems. Then we write the corresponding leaf with each stem. Leaf or leaves, depending on if there's more than one. You arrange the leaves in ascending order, and you create a legend to indicate what the values represent. So I think it's much easier if we actually just do an example. So here we have 2-digit numbers. So the leaves are going to be the rightmost digits. So what I've underlined in blue is the leaf. The stems are going to be the leftmost digits. So the stems are what I'm highlighting in blue here. So if you look, our data ranges from 42 to 99, and a little tip here. Arrange the data in ascending order to start with. It will make your life easier. So we have 42 to 99 as our range of values. So first let's write our stems. So we have 4. Our next value is a 67, but we still need to put a 5 in there. 6, 7, 8, 9. So this column is the stems. We don't usually label it as stems, but I'm going to so you know what's what. Then we draw our vertical line. And on the right side of the vertical line, we put our leaves. So we have a 42, so we put a 2 there. We don't have any data points in the 50s, so we leave that blank. In the 60s, we have a 67, so we put a 7. For the 70s, we have 2 data values. We have a 73 and a 78, so we have 2 leaves, 3, and then we leave a space and put an 8. So we always put the smallest leaf right next to the vertical line, and we get bigger as we go to the right. So for the 80s, we have 82, 84, and 86. And for the 90s, we have 91, 94, and 99. So that's our stem and leaf plot for that data set. So notice a stem and leaf plot looks kind of like a histogram that's been turned on its side. There is one advantage that the stem and leaf plots have over the histograms, and that is that we can see the raw data from a stem and leaf plot. And I should go back. I was bad here. I did not make my legend. So, for example, we would just put legend. And then we can pick any value we want, but let's just pick the 73. So 7 line 3 equals the data point 73. So back to the advantages and disadvantages. We said the advantage of the stem and leaf plot over the histogram is that we can see the raw data values. On the other hand, they lose their usefulness when the data sets are very large. Then it's just tedious to make one, and it doesn't really matter what the raw data is at that point. So the reason that it's annoying when the data sets are very large are because we're forced essentially to use a class width of 1 when we use a stem and leaf plot. And sometimes we'd rather have a larger width. Okay, I know that this is not going to be in your notes, but I'm going to go do a second example of a stem and leaf plot because I know there's one that you will see in your homework. So we have the following data that represents the ages on the ceremony date of the Academy Awards. The winners for Best Actor and Best Actress in a Leading Role from the years 1978 all the way to 2014. And what's different about this one is they want us to construct a back-to-back stem and leaf plot. So for back-to-back, it's a little bit different. So we're still going to have a stem, but it's going to look more like a tree because we're going to have leaves on both sides of the stem, not just on one. So the first thing we need to do is look at the minimum and maximum data values for each data set. So the minimum for the actors looks like it's 30. And the maximum for the actors is 76. Okay, let's go do the same thing for the actresses. Remember, we're doing this because we want to make sure that we don't forget any of our stems. So the minimum age for an actress looks like 21. And the maximum age for the actress appears to be 80. So that means we have stems going 2, 3, 4, 5, 6, 7, 8. We're going to put a vertical line on either side of our stem now. And we're going to do the actresses on the right, and we'll do the actors on the left. Just because I put the actor table on the left and the actress tables on the right. We could do it the other way around. So I'll leave it to you to arrange your data for each table in ascending order. But when you do, let's start with the actresses first. So that is just like the last example we did. We do each leaf in ascending order as we go towards the right. So we would have for the 2, 1, 2, 5, 6, 6. Notice we have 2 values of 26. So that means we have to write the 6 twice because we have 2 leaves of 6. Then we have 8, 9, 9. Moving down to the 30s, we have 0, 1, 2, 2, 3, 3, there's 5 threes, 1, 4, 2 5s, a 6, and a 9. To the 40s, we have 1, 1, 2, 4, 5, 5, 9, 9. There are no actresses that were in their 50s, but for 60s, we have 1, 1, 2 as our leaves. For the 70s, we have 4 as a leaf, and for the 80s, we have a 0. Now, the actors work the same way, except it's like a mirror image. So the smaller numbers, remember, are always going to be closest to the stem. So when we do the actors, we had one person in their 20s, which was a 9. In the 30s, we had a 30-year-old, so we put the 0 there. And then this time, we get larger as we go left with the leaves. So we also had 2 32-year-olds, 2 36-year-olds, 3 37-year-olds, 2 38-year-olds, and 2 39-year-olds. For the 40s, we had 0, 0, 2, 2, 3, 3, 4, 5, 3 5s total, a 6, 1 7, and 1 8. For the 50s, we have 0, 0, 1, 2, 3, 4, 5. 60s, we have 0, 0, 2. And for the 70s, we had a 6. Now you'll notice that I try to keep my numbers, my leaves, all lined up so that I have a good visual representation of where the majority of the data lies. Anyway, that's how you do a back-to-back stem and leaf plot. And we'll pick up in the next section with talking about dot plots. The next video, sorry.